So in this problem we have f of x is equal to the product of 2x minus 5 and 4x plus 3. So for f of 2 we would just plug in 2 into the original function f of x. So we'd have, so here we'd have 2 times, f of negative 2. So 2 times negative 2 is negative 4, minus 5 is negative 9, times 4 times negative 2 is negative 8, plus 3 is negative 5. So the product of negative 9 and negative 5 is positive 45. Then for f prime of 2, well, before you can find f prime of 2, you need to find f prime of x. So there's two ways. You could use the product rule with it as it's written, but it would really be quite a bit easier, a lot easier, if you just FOIL first before we differentiate, because then we can just use the power rule. So if we FOIL first, we'll have 2x times 4x is 8x squared. 2x times positive 3 is plus 6x. Negative 5 times 4x is negative 20x. And negative 5 times positive 3 is negative 15. So the middle terms simplify to negative 14x. Alright, so that's the regular f. Now we can take f prime of x. Using the power rule, we bring the 2 down, times the 8, we get 16x to the first, minus 14 is that derivative, and that derivative is 15. So then to find f prime of negative 2, we can plug negative 2 in right here. 16 times negative 2 is negative 32, then minus 14, so that's going to be negative 46. And then for f double prime, we take the derivative of f prime. The derivative of 16x is always 16, and the derivative of the constant is 0. So f double prime at all values of x is always positive 16. Now the values for which f of x are 0. Okay, and we're going to find the values for which f prime are 0. To find where f of x equals 0, we would set the original function equal to 0. I would set this factored version, because it's going to be easier to solve, equal to 0. So setting f of x is equal to 2x minus 5 times 4x plus 3 equal to 0. We have this. We set each factor equal to 0. So we get 2x equals 5, where x is 5 halves. Over here we'll get x is negative 3/4. Are the two values of x where f of x equals 0. Then to find where f prime equals 0, we would set its derivative equal to 0. So here's f prime. Okay, if we set that equal to 0, we'll have 0 equals 16x minus 14. So 14 equals 16x. So x is 14 over 16, which would reduce, let's see, to 7/8 is where the derivative equals 0.